Hello. I'm going to be talking about this concept that I made up called the operations dividend. I know it doesn't make a lot of sense right now, but hopefully by the end you'll be able to get an idea of what I'm talking about here. I'm going to be talking about how development and operations can relate together. My world, well, first of all, I just want to back up a little bit and say I'm super excited to be on stage here in Seattle. I've been in Seattle for about 20 years. I started my career at Microsoft and then Google and now Heptio. And it's so great to see an event like this where really there is so much going on in the cloud space. And I hope we see more from GeekWire and more from this event series over time. So just want to get that out of the way. Super excited about that. So my world, I was at Google for about 10 years, and I really grew up, in terms of like how to build software on the server at Google. And so much of my thinking is really imbued with how Google approaches this stuff. And as I built out Compute Engine, and then as a set of us started out with Kubernetes, the really big challenge there was figuring out how do we take so many of these concepts that have, worked so well for Google for quite a while now, and how do we adapt that to a larger world? And so a lot of what I want to talk about here is about like how do development and operations work in this new world, and how do we actually map that back to the common structures that we'll see in typical IT organizations today. Because there is a gulf there, and we have to figure out how to bridge that gulf. So that term, in terms of that new world, I think, we don't have a good name for that. I think cloud native is a great place to start. Kubernetes, my co-founder with Heptio, Craig McLuckie, started this foundation called the Cloud Native Computing Foundation, with the idea to bring together a bunch of these technologies and a bunch of this thinking into one place. And so Kubernetes at this point is curated by the Cloud Native Computing Foundation, the CNCF. So one thing I do want to actually point out here is this is the Cloud Tech Conference, but you don't have to be running on cloud to actually take some of these ideas and make them useful. I think the concept of cloud is in some ways a spectrum, and so you can actually take a lot of the ideas that make things work well on cloud and apply those wherever you may be running your workloads. So with that, I'm going to be talking about development and operations and how these things relate together. So obviously I'm talking about DevOps, right? Well, actually, I don't know. I don't know what DevOps is, and I bet nobody else in this room really knows what DevOps is either. It's a little bit of a fuzzy term. A really cynical view here, and this comes from Kelsey Hightower, who's now a developer advocate at Google. And he said that DevOps was group therapy for large companies. So you got the operations team and the development team, and they hate each other, and so you pay some, high-priced, workshop to get them in the same room and actually get them to talk, and you get a campfire and sing Kumbaya. That's a little bit unfair, though, because I think there is a kernel of truth here. I think the traditional way of doing operations and development is very much this sort of throw it over the wall. And listening to Scott here, up here talking about Azure, I think that one of the big changes that Microsoft, and I started at Microsoft a long time ago, one of the big changes that Microsoft has had to go through is moving from a shrink-wrapped mindset to a continuous delivery to a sort of, how do we actually take advantage of the unique opportunities to build software in this sort of, server-side cloud-delivered model. And as part of that, you have to change how your development and operation teams actually relate to each other. So the traditional model is development builds some stuff, they test it, it's done, they throw it over the wall, they have no idea what happens in operations, right? And in some ways that's a caricature, but there's a spectrum of sort of with-itness when it comes to that stuff. The new world, we don't have that luxury. Development teams have to build software that is operatable. And operations teams have to take the learnings from what happens as they develop that software and plow that back into the development cycle. You have to be able to have these things learn from each other and really get this virtuous cycle of feedback between these two teams. All right, so I've already said I don't know what DevOps is. Let's talk about microservices. So as I like to call them, services. This is, again, another fuzzy concept. One of the interesting things here is as software engineers, through the history of computer science and software engineering, the theme is that we take big problems, break them down into small problems, solve those, and then build them back up. Right? We have modules back in the day with C, and then you have object-oriented programming, and we have DLLs or shared libraries or COM objects or what have you, right? We've done this again and again and again, and we're always turning over new technologies, new ways to break problems down and build them back up into more complex, more fully functional systems. Microservices are just a continuation of that journey. Whereas before you had, a runtime or a linker that was actually bringing things together on a single machine, with microservices, we're taking that linker and we're moving it into the operation space. So we're taking something that was fundamentally a development time concept of actually bringing these parts together, and we're moving that to be a production operational time concept of actually connecting these things over the network. And so your discovery service, and when I say discovery service, I mean like a DNS, like a naming service. It's a really fancy name for just being able to name things. Your discovery service becomes your linker in this world. And that's a good thing, right? We're just seeing these trends that we've seen before, but we're moving it into the operational space. So it's fundamentally about building blocks. And I'm going to be talking in a little bit about the different types of building blocks, because I think in this new world where we're building this stuff and we're moving this into the production operational space, we have a lot of opportunities to actually use these building blocks in new and more interesting ways. The advantage here is scaling. And a lot of times when somebody says scaling in this context, they're really talking about how do I handle more traffic? How do I handle growing the solution in terms of the amount of capacity that I'm using? But the real benefit here, and you get that out of these microservices because you now can spread this stuff out over the network, and that's a good thing. But the big advantage for most users is about scaling the organization. So Jeff Bezos has this idea of 2 pizza meetings. Have you heard this, right? It's like no meeting should be larger than, the number of people should be larger than you can feed with 2 pizzas. Folks have extended this to talk about 2 pizza teams. As you get larger and larger teams, they naturally get less efficient. The amount of communication that's necessary is, the square of the number of people on a team. So as you get larger and larger teams, they are not able to actually gel and sort of mind meld and communicate as effectively as you'd like. So there's this general idea of let's keep teams small, let's keep them approachable. 2 pizza teams instead of 2 pizza meetings makes a ton of sense. And so these new processes of being able to take these problems and break them apart lets you keep teams efficient and small and decoupled from each other. And so it's really about scaling the organization as much as it is about scaling the application itself. The end result here is velocity, right? This is what the business value is out of so much of what we're talking about here. I want to ship more product faster, more reliably, right? I think, my bank's website updates once a quarter. Apps on my phone update every day, right? What's the difference between these? And I think how can we bring some of that thinking of being able to deliver value faster, more reliably, to not just new greenfield technology forward companies, but to a much wider audience. And so that's what we're really looking to get out of this new cloud native world. All right, let's go into some details on this service spectrum. I think there are different ways to look at and use services, and I think there's different levels of maturity and choices to be made here. And as we go through this, I think you'll understand that this stuff starts out useful, but over time it actually becomes something that you can rotate an entire business around. So the first thing here is a service as an implementation detail. This is sort of the traditional sort of like, I take my application, I break it into parts. Those parts are relatively decoupled, and then I form it back together as an application. The key thing to look at here is that any single service in this world has, one or two consumers of that service. There's a danger here that the services can become too tightly coupled, and you end up with this sort of distributed monolith. Right? So if you're not careful, you sort of go through this sort of microservices theater of breaking all these things down, only to have to go through and actually release them as a single unit. But if you do this right, you get that advantage of decoupling, you get that advantage of having teams operate independently, and it's great. So the next step here is, and I don't have a great name here, shared artifact private instance. Your database is a service, right? I mean, like somebody's running it, it's running on a different machine, you access it over the network, it has a well-defined interface, there's a separate team that actually builds and runs that, right? That meets all the criteria that I've mentioned so far in terms of what a service is. Now, the interesting thing here is that your database, the program and the team that's building that and packaging that up, they're highly leveraged because they're building one artifact that gets run multiple times, and you enable a certain level of reuse there. And this doesn't apply just for off-the-shelf software like something like a database. This also applies for stuff inside of your company. You may find that you have some expertise that you want to be able to package up so that different teams can use it. Well, you can deliver to them some sort of artifact, a jar file, a Docker image, or what have you, that then they can go ahead and run for themselves and have their own private copy. That's a first step in terms of being able to make services be more highly leveraged across an organization. The next step here is shared instance. So this is what I've been calling in some ways sort of soft multi-tenancy, right? So you have a set of technology that is useful beyond a single application. And so across the organization, you run, or a team runs a single version of this that gets used by a bunch of different apps. And I'll give you a couple of concrete examples of where this might make sense. I mentioned my bank's website. I go to my bank's website, and I go to my 401k, I go to my checking account, I go to my investment accounts, and it turns out that those are actually probably at least 3 different applications behind the scenes, probably more like 10, right? And they try and sort of like keep this facade to make it look like one app by having branding and common UI elements. Now the bank goes through a rebrand, and they have to update the logo across all these sites. This is a big project now, because now not only do I have to update the logo in one place, I have to update it across the 3 to a dozen different applications that make up the experience. Here's how you can solve this problem with microservices, and it's very easy. As you're rendering out your HTML page, you make a call to a service that renders your branding bar, right? Get the HTML, composite that into your page. Right? That's a shared service, right? You can have a team running the branding assets. You call into that, everybody brings that together, and then you're still running separate applications, but they have a shared service behind the scenes that pulls together all the branding for this stuff. So now when you want to do a branding update, or if you want to do a holiday logo, or if you want to do some sort of alert, you have one place to go to be able to change that and roll it out across your entire application. And you can define a well-defined interface and API across these things such that you have confidence that you can actually make changes on that shared branding service and update the rest of the sites. A more interesting example here. You might, as a company, develop some really core, interesting technology that you want to share across your organization. So imagine you're a car manufacturer, and you come up with a machine learning model that takes a photo and tells you the make, model, year, and options on a car out of a photo. That's a really useful thing, right? And that's useful for both doing, say, brand recognition by trolling social media to actually find who's actually posting pictures of your car. But you could also build a consumer app where you can take an app and maybe text it and get a link that has a pre-configured thing that says talk to a sales guy, right? So that's a common asset that's very domain specific to that company that you can then share across the entire organization. And I think if you enable that as an internal service inside of that organization, you'll find that creative people will do creative things with it. All right, so the last step here, and I'm not going to spend a lot of time on this, is what I've been calling big S service or hard multi-tenancy, right? So in that soft multi-tenancy thing, if somebody's doing something wrong, you call them up and you say, stop doing that, you're hurting us, and they do. And if they don't, you fire them, right? I mean, hard multi-tenancy is that you may have state actors attacking you, and there's a whole bunch of extra things that come in when you're offering this as a commercial service for all comers. If you don't go to that level, things get a lot easier. All right, so if you do this right, you move from this sort of like very segmented world of applications broken into services to essentially a service network where you have services calling services, and you provide essentially a high-level platform across your organization that becomes business value that you can build on for years to come. I think another name that folks have been giving this is a service mesh. Right? So it's a way to start figuring out how to leverage your assets and your core competencies that you're building up around your business more widely across the entire organization. All right, let's switch gears a little bit and talk about operations, because I've been talking about mostly development and services up until now. Operations is a little bit of a different beast. Okay, so DevOps, a naive reading of DevOps is that everybody is in everybody's business, right? You want to hire the full stack person that handles everything down to the OS. That works when you're at a startup. That does not work when you're at a large company. That does not work when you have all sorts of requirements that require deep level of expertise. One of the interesting things that we've done with cloud is that we've essentially, like if you look at IaaS, right, VMs, that's really hardware ops as a service. We've taken one level of the ops stack, we've clearly defined that, put it behind an API, and made it somebody else's problem. The problem is that we stopped there, right? What's going on inside of a VM has generally been left as an exercise to the reader. And so how can we actually start creating new gradations in terms of operation specialization where I can actually have a dedicated team for solving some of these problems, or in the limit, make it somebody else's problem so that I don't even have to think about it. So at the lowest level here, we have OS operations. And this is both a mindset in terms of how do I actually run an OS and upgrade it and manage it in an effective way with, in essentially, application neutral way, coupled with new technologies and new products that people are building that are purpose built for this. If we look at, Red Hat Atomic or CoreOS Container Linux or, VMware Photon, there's a whole host of OS distributions that are pared down so that their only job is to get to the point where they can run containers. That's a real change, and that actually is a change both on the product side but also on the operational side. If all you need to do is manage running an OS to the point where you can run a container, that's a simple, separable, clean problem that you can make somebody else's problem or have a dedicated team for. The next level up, and this is where my heart is cluster operations. Inside of Google, the cluster system is called Borg. It's the precursor for Kubernetes. We stole a lot of ideas from Borg as we built Kubernetes out. And there is the Borg SRE team. The Borg SRE team is a relatively small set of highly skilled people that manage Borg over a ton of machines. And on a day-to-day basis, you don't have to talk to those people. They offer an API to you. They offer a service. That service is well-defined. It turns out that the ads front-end SRE team at Google talks to the development team a heck of a lot more than they're going to talk to the Borg SRE team. That clean interface there really truly lets you start treating a set of virtual machines as a single interface, as a single thing that you're working with. And in some ways, this is a continuation of the idea of cloud, but we're up-leveling it to be sort of container native versus actually being based on a physical abstraction like VMs, right? So logical infrastructure versus physical infrastructure as a service. And then the top level here is application operations. I mentioned that there's the ads front-end SRE team, and then there's the ads front-end development team. right? So for small products, the application operations role can be played by the development team, and you actually do have sort of a form of DevOps at that point. But as projects grow, as they get more complex, as you want to have somebody who's actually, bright-eyed and bushy-tailed, to handle pages, 24/7, you have to be able to have a specialized organization for doing operations. And so you can split out operations from development here. But the big change from the traditional IT model is that this operations team is tightly aligned with the application development team. Instead of having a generic operations team that can handle, 1,000 different customers across your organization and is being pulled in so many different directions, now you have an operations team that is really focused on that application. And in doing so, you don't end up with these tensions of differing priorities that you get in the more traditional model. So when you align the applications operations team and the applications dev team, you get much happier teams and much better outcomes out of this. All right, so as we build new tools, cloud-native tools, Kubernetes, containers, all the tools that come around with this, around observability, around tracing, around management. As we build up all these things, what we're really doing is we're making it cheaper and easier to run more things in production. Right? So as we rewind and we start looking at microservices, microservices sound great on paper until you realize you have to run more crap in production. And every new thing that you run in production has a cost, right? It's not free to actually run a new service. There's a huge ongoing cost to that, right? And so you have to balance out the benefits that you get from microservices with the cost of running these things. On the operations side, as we build these new tools, we actually reduce the cost of actually running new things in production. And in some ways, this is really the operations dividend, right? As we reduce the constants in the formula for running new services, that introduces more operational capacity. We can take that operational capacity and we can do a couple of things with it. We can give our operations folks a weekend off, right? Or maybe we actually take them down to 20 hours a week. Or what we can do is we can take that extra operational capacity and let the development team use that to actually be more effective and to actually realize the promise of things like microservices. So that's what I mean by the operations dividend. If we make operations more efficient, we can take that benefit and we can use it to make developers more effective. And the end result is that we ship more products faster, more reliably, and businesses see real value out of that. So thank you very much.